Alright, welcome back to my daily Leetcode problem. So, daily Leetcode problem is earliest finish time for land and water rights. 1. That means there could be 2, 3 or something else. I don't know. We are given two categories of theme park attraction, land rights and water right. So, land right is given with the two types array. One is land start time, which is the earlier times in the interest land right can be bounded. The second one is a land duration, how long the land right lasts. And the same for the water rights. So the earliest time the water right can be bounded, and the water duration is how long the water right lasts. So we are supposed to be the tourists in exactly one right from each category in either order. So we could start with the water rights or we could start with the land right. So based on the time availability, and a right may be start at its opening time or any later moment. So if a right is start at time t and it finish at time t plus duration, so immediately after finishing one right, the tourist may bounce to the other, so which is already open, or we have to wait until it's open. We have to return the earliest possible time at which tourists can finish boat ride. I think this is a greedy algorithm type of problem, because how do I know is we just solved the one greedy algorithm problem yesterday. So let's consider and try to understand the given XML one. So the plan is we start with the right for the land right 0. So land right 0 start at 2 and at 4, which means totally we took the time of 6. And the water rights, which is only 1 at the moment, start at 6. So we could start immediately at 6 and finish at 9. So that means the total time span on our plan A is at 9. How about plan B? We start with the water right. So start at 6 and end at 3, which is make about 9, and maybe we can join the land start time, which is 8, because it's already started at 8 and we can unbolt at 9. So 8 plus 1 is totally 1, and 9 plus 1, so which is the duration, which began 10. Okay, how about plan C? So we have chosen like water start and land start. So if start from land, we have 2 options. Start from water, we have 2 options. So start from land, we have 2 land and 1 water, 1 water. So we have 4 approach totally. So start with let's go for the plan C. We will start from the second land, which is here. Start at 8 and as 9, which is 9 already, and then we need 9 plus 3, which is 12, so which is also not a good number at the moment. So let's go for the plan D. Start with the water and at 9, and then we goes to the 4. So 9 plus 4 is 13. So among these 4 plans, we decided to choose the earliest time, which is 9. So we could only spend total 9 duration, and we could enjoy our 2 rights for both land and water rights. How about example 2? Okay, this is quite straightforward because only 2 approach we can consider, because only 1 land and 1 water. So we start at 5 for the land and at 3, which is total duration of 8, and we start at 1 and 10, which is 8 plus 10 will be 18. How about we start at water, so which is 10 total, and we end up for the land is the wait, okay, 1 plus 10 should be the 11, and then we start at 5 and end as 3. 11 plus 3 is totals 40, so we decided to choose the 40. I think the only idea I can consider right now is maybe we try the double for loop. What I mean by double for loop is start with the water or start with the land, whatever. We start first and then we do the alternative, and we will compare it with the minimum for each answer. Let's call the answer initially the integer of mass, and let's call land count. Let's check the constraint first, because in here it's given like the start time and duration of the land and water will be the same, so we can simply take one. Land start time dot count, water count, a little bit weird naming, water start time dot count. So okay, let's start with land first because we are still in the land. Let's call land index, which is more makes sense, in 0 through land count. What I'm going to do is let's call land finish time. That will be land start time of land index plus land duration of land index, and we will go through to the water index 0 through water count. And what I want to do in here is let's check the water start. That will be water start time of water index, but we need to check. We can only take one for the maximum in here, because what if our land is not finished yet at the time, and yeah, what if the land is not finished yet and the water already starts, so we have to wait for the land to finish. That's why we have to take the mass. The same approach, what if the water start first and then land is not finished yet? I mean, like land is finished and water already start, so we have to take the water. Cool. And next is the answer. Let's consider a finished boat. That will be the water start plus water duration of water index, and I can simply update the answer for the minimum of answer and finish boat. I think I can just copy and paste in here. I will simply update the here water count. Let's call water finish. That will be water start time and water duration, and that is supposed to be the water index. So water index, and I can replace this land index in here with land. Maybe we call land finish. Yep, and maybe land start time and water finish, and that would be the time, and which is supposed to be the land duration. We are supposed to use the land index. Finish boat, answer, return the answer. I think that is pretty easy. Not sure I'm good at it really, or the problem is supposed to be easy. Let's try to submit it. Alright, okay. Okay, let's check the time complexity and speed complexity together. So I think it's O of n plus m because we have a two loop going through one after another. So which is say O of n into m, the memory will be the O of 1 because we don't use any spare extra memory in here. Alright, cool. Hope you guys enjoy my second types of greedy algorithm, and see you in the next one. Bye.